3, 2.
Hi, my name is Bradley. I'm going to share with you today how to build a hang frame. I've built A-frames for a lot of years, and in fact I think I've built over 150 of many different designs, and of them all, the hang frame is my very favorite style. And the reason being, easier rigging, stronger, easier to build, lighter weight, and all around just nicer. There's many different styles of A-frames. There's the A-frame, which is the A-style A-frame, is what you see right now. Then there's the X-frame, and then there's also the T-frame. The T-frame is just the one where you have the two parallel boards, the base, and then you got some diagonal boards there to hold it up. The T-frame is nice, it's really strong, but it's a pain in the butt to build. It's a lot of weight and a lot of materials. It just takes extra effort and is not necessary. So with the A-frame style, actually if we go with the X-frame style, the X-frame is a really simple A-frame to build. It's the easiest to build of them all. You can just slap the boards together, throw a bolt through it, or lash it with some rope, and then you can have a rope for the bridge down at the bottom. And it's super easy to build, but the problem with the X-style A-frame is that you can actually have some problems with how the load goes down along the plane of the frame. So what I mean by that is that when you apply a downward force to an X-frame, because the one board and the other board are offset from each other, they're going to apply the force downward in a twisting fashion because they're not in the same plane. They're actually putting some added stress into the A-frame when you have it not on the same plane. So the X-frame just kind of twists when you put this downward force. And if you built an X-frame before, you've seen exactly this thing happen. And if you build a tall X-frame, then you start getting a little bit scared because you're seeing how much it flexes, and then people don't typically make tall X-frames. Now with the A-frame, the A-style A-frame, the force is applied along the same plane. It's the two boards meet, the two legs meet, and then they push into each other and they apply the same force, but they don't really have anything that compels them to twist. Unless the boards are really wonky and twisted themselves, the force is just going to be basically downward through the frame. That's what makes the structure stronger and nicer. Now, you have four components to an A-frame. You have the head, the legs, the bridge, and the feet. And sometimes the bridge can be a rope. When it comes to an A-frame style, A-style A-frame, be it a hang frame or a over-the-top A-frame, I prefer the bridge to be made out of a solid piece of something because then you can prevent the legs from twisting on each other, and it's just a little bit better. With the X-style A-frame, you just need a rope, and that's super easy. Now, with the bridge being on the frame, it's kind of important how high you have the bridge on the frame because that's going to dictate the amount of force that the entire internal structure takes. As you notice, this kind of looks like a triangle. And a triangle is the strongest structure in the universe as far as we know. And so if you have a triangular structure here, when you apply all the forces to it and each point is fixed together, you're going to end up just applying the forces in the strongest way you possibly can. But if you have, for instance, the bridge sitting way, way up on the A-frame, you're going to actually have these quite large lever arms that are going to be trying to move outwards and apply a force outward on this. And it's going to put stresses, internal stresses on the frame and generally weaken your frame. So I like to have the bridge about 30 centimeters up on the feet. Sometimes I might have it a little bit higher because, for instance, there will be, for instance, on a highline application, there might be a rock right in between, and I want to avoid the rock, have the feet sitting nicely on either side without having the bridge touch the rock, or whatever reason. I might want the bridge to be a little bit higher, but generally I try to keep it as low as possible while still having enough of distance on the feet to make it adaptable to most surfaces. So here we're going to build a hang frame. It's really easy, really simple, and really quick. When you're building any type of A-frame, your material selection is pretty important. You know, when you go to the lumber yard, and you pick out wood that's kind of twisted or warped, it's going to translate to, you know, a weaker A-frame altogether. And so when I pick wood from the lumber yard, I'm going to try to find the wood that has the least number of knots in it. This is a knot. That's a knot. You don't want all these little knots in the wood if you can avoid it, because that's just going to weaken the wood. Now, small knots like that are really not that much of a problem. But when you have these really big knots that take up the entire thing, that's going to weaken your wood, and you just can't use that. So the other thing you want to notice is how straight the wood is. So when you pick out your wood from the lumber yard, you're going to look down the length of the wood and see how straight it is. And this piece is fairly straight. It's got just a little bit of a curve to the left there, but it's no problem. So you look down the length of the wood, and then you can see the twisting or curving or bending, however you want to say it. You're going to just try to select the pieces that are least twisted and least knotted. You can get different types of wood. This is just about the cheapest wood you can get in the United States. This is called Douglas fir, and it just also happens to be one of the strongest woods you can get. You can get lighter weight woods than this, but they're not as strong, and they're a lot more expensive. I chose this wood because these were $4 per plank here, and that's really all I need. I would prefer to have a larger profile. I would actually prefer to have a square profile here instead of this rectangular profile. And the reason for that is when I drill through at the head, I want to have a little bit more play. When I put the hole through the head, I have to go through the long way on the wood. And if I get off a little bit, that's where I can lose some strength with the A-frame. So when I'm building an A-frame, first thing I'm going to do is just lay it out, take a look at it, and get the right idea of what I want to do. And I can just very quickly and very easily put the boards on the ground, and then lay them out as I expect them to be, and then spread the feet as I generally would expect them to be. So when I decide on how far apart I want the feet, I just take it easy and I just go half the length of the wood, and that's almost always going to be perfectly enough for this. If you really spread the feet too far wide, too far apart, you're losing height on your A-frame, you're increasing the stresses on the A-frame, and you're really not getting much of a benefit. You might think that you get more lateral stability from the A-frame moving side to side, but I found that with this half the length measurement that I use on a 4 meter tall A-frame that I did a test on, I had 6 people pulling sideways on the slackline, and with all of our strength combined, we were just able to get the A-frame to start toppling over. So there's really, you don't need to have the feet too wide. It's just a waste of your materials, height, everything. You don't need it. So in this case, I'm going to go, these are 8-foot boards, 240 centimeters. So I'm going to go half that length for the spread of the feet. And so I'll just put this out to 4 feet, about 120 centimeters. I'll realign the head here. And now this is the general shape that my A-frame is going to take. So next I'm going to, again, I want to make sure that the bridge is not too high. So I'm going to just measure up from here. Usually I go with about 30 centimeters. That's my good compromise meeting point. So I'm going to put a mark in here for 12 inches, 30 centimeters from the bottom. And do the same on the other side. Go with about 12 inches, 30 centimeters on that point right there. Next, bridge. I don't want the bridge to be all the way at the end like this. And the reason being is, remember that these feet are going to want to spread apart. So if I was to put a hole right here and put a bolt through there, I only have this much of the wood to protect from that bolt just splitting straight out. You know, the bolt's going to want to split the wood naturally. So I don't want the bolt to be right at the edge of the wood. So I'm going to give it a little bit of space. And usually I go with about 8 inches, 20 centimeters of space here. So I'll just pop in a little mark there and go halfway here. It's 75. So I've got my mark for where my first bolt goes for the bridge, and I got the mark on this one here. So from here, I can go ahead and start drilling. now that I have my holes made, I can take my carriage bolt. You can see this little profile here up at the head. The reason I choose to use a carriage bolt instead of threaded rod or any other type of bolts, if I can get my hands on this, is that I just have to put this through, and then I can then I don't need a wrench on this side of the bolt. I can just put it into the wood. That square head will bite into the wood and hold it steady for me, so I don't need to have 2 wrenches. And actually, I don't need to have any wrenches at all, because my other side I use a wing nut, so when I'm out in the field or wherever, I don't need to carry a wrench with me to take apart the A-frame. I just use this wing nut, and boom, it comes right apart. So, put my carriage bolt through. Put my washer on and my wing nut. Oh, I meant to put the bridge on the other side. All right. Should I flip the whole thing over? No. Let's see what I can. Yeah. Okay. I'm gonna flip the whole thing over. Oops. All right. Put the wing nut on. Now that I have my bolt already placed there, I just once again realign how much I want the feet spread on this. Go out with another 48 inches, 120 centimeters. All right. So I have an approximate point where I want to put this. Again, this doesn't have to be that accurate. It's not a precise calculation for that. It's just generally how much you want to have it spread. So now that I have that, I can put my mark through here, and I'm just gonna again put it wherever I want. I don't have to have it perfect. I don't have to measure perfectly on here. I'm gonna put this mark in, and then from this mark I'll end up cutting this last remaining piece off. So put that through there. And again, put my mark in here. I've already got this marked before. And I think I'm just going to turn this whole thing back over. Yeah, that's what I'm going to do. Oops. There we go. So now I have the general shape of my A-frame set up. All right. Now what I'm going to do is measure to the middle point of my bridge, and from here, this is where I get to do a little trick to end up making the cuts for my head really, really easy. So I take a middle point measurement from, let's say, let's make sure that these are even first. So I'll take a middle point measurement from here, so that's about 42 inches. So I'll go to 21 inches, make my mark. In fact, I'm going to go on the inside here and make it, yeah, it's 41, so 20 and a half there. Right, That's 41 inches, 20 and a half is middle point. Boom. So once I have that mark, take a string and put it through. Now if I tighten this string down right to that middle point there, I can bring this up to my head, and I can use this to make a perfect mark of where I'm going to make my cuts for my head. I've got my head very nicely aligned up here. So the reason why I'm using a string like this instead of just taking a block and then just putting marks with this block is because the fulcrum is already set for this lever. When I close the lever again, if I was just to use a block and I cut out these parallel lines out of the block and I close the A-frame again, I'm going to have this little gap in between there. Whereas if I make these marks open like that, when I go to close the A-frame, the head is going to mate perfectly even. So now the size of the cut you're going to make here, I don't think you need to make a really large cut going along here. Personally, I think that's wasteful and you don't get anything out of it. It makes your hang point hang lower. It makes the contact surface bigger, but you don't actually have to worry about the contact surface being that large. You'll see why soon. So I'm going to make this. I actually want the contact surface, I want this whole head to be pretty small. I want it to be about the same amount that I'm going to cut out. This little triangle I'm going to cut out here, I want this to be about the same as the width of the board here. I'm going to just get my measuring tape so I can be sure that both my cuts are going to be the same. So pull this tight, measure how much over I'm going on it, and let's see, that says, let's go with even number of 2.5 inches, about 60 millimeters or so. So I can just make my mark here, and boom, I've got my line. So we'll do the same on this side. 2.5 there. Pull that tight. It's 2.5. About there. I think, did I? Yeah, okay. All right. So that's 7/8, and that's 1 inch. Yeah. Okay. I didn't account for the width of the string. I did it on the wrong side of the string. So I'm just gonna pull that tight again here and try again. Okay. So now I made my marks on both of the same side of the string. So on the outside of the string there and outside of the string there. And that is 1 inch. So now I've got these marks here, I can start doing my cuts. That's hopefully about stable enough. And I don't have my safety goggles with me, so I'll just use the squinting safeties. Hopefully that'll be fine. Alright, so I'm going to line up my saw with my cut. sure that I've got contact there. All right. And nice. All right. And do the second one here. Now I've got my two cuts made here, made the faces, and boom, they line up perfectly. Nice and straight cuts, straight lines, and it's done. Next, going to be making the hole for the hang sling. Almost got it there. So to make the hole in the hang sling, I'm going to want to take a point from here and a point from here. I'm going to try to make an X through here from to a solid distance away. So the other thing I could do is actually, I don't think I'll make the X in fact, because these cuts are not exactly the same. So what I'm going to do instead is just measure down about 50 millimeters to 2 inches or so down here, and then make a middle point there. That's really important that these holes that you drill through here are the same level on both sides. So when you find your hole, wherever you're going to put that, you want it to be the same level, and you want it to go through perpendicular to the board here. You don't want to drill in from the outside here, because then you're going to have the hang sling is going to, well, you see why you can't do it that way, but you want to be perpendicular with this, because this is actually the direction you want it to go. So I'm going to go ahead and measure down here, go from the edge. Let's see. I'm not a professional carpenter, so if I'm not doing this the way you do it, that's all right. I'm going to go with 1 3/4 inch in there, and that's about roughly about there. Go to the middle point, and we're going to go with 0.75 and do the same thing here. I'm just going to confirm that from another measurement. Yep, and perfect, bingo. Now again, it's really important that this hole goes through as straight as possible. You're going to lose a lot of strength out of this whole frame if your hole goes, if you're drilling through and your hole goes at some kind of weird angle and comes out the side here or whatever. So I would prefer to have a drill press with a vise or some other thick solid thing where I can have a very true hole going through, but I don't have that, and I don't want to take too much time making this, so I'm just going to try to eyeball it as best as I can. What you can do also is get a smaller drill bit to start out. In fact, I'm going to do that so I can, if I do make a mistake, I can fix it a little bit easier. All right, here we go. So again, I'm going perpendicular to the face that I cut. looks pretty good from this angle. Do the same over here. Yeah, looks pretty good. All right. And you can see here, came out pretty much dead in the middle of this hole here. So that one turned out to be almost perfect. About as good as you can get doing it by eyeball, if I do say so myself. All right, that's good. And this one was much further off. You can see I didn't hold the drill nearly as level. I also have this chunk that kind of throws off the view. But I think I'm off by 1/8 of an inch, maybe 2 millimeters or so off on that. Not terrible, but definitely would prefer to have it much more even than that. All right. Now I've got the holes in here. And if we look through, you can actually see that the holes are pretty well aligned. You can actually see, there's my eyeball. Hello. So now I'm going to get a sling and shove a sling through there. Where are my slings? A whole big thing of them. And there they ain't. Where did I put my slings? And right there. Well, they don't appear to be in this one. I think this is all whoopies in here. All right, third time's the charm. Let's try this one. All right, there they are. So let's see. Yeah, we'll just go with this slightly longer one here. All right. So, just kind of thread my sling through the hole. Hopefully that fits all right. There's one end. Yeah, that's one side there. All right. Put that through the other end. And we have a hang frame. I want to fix these and make sure that everything's nice and even as it goes through there. There we go. Now, the true benefit of the hang frame is, of this sling style hang frame, is you have this alignment hole here. You have the force of the slackline that's going to be pulling down on these slings. And I'll show you how that's configured in just a minute. But the natural force that's going to happen here, it's going to naturally want to close these up. And I know it's not a very good example here as it is, but the natural downward force of these slings is going to pull this together and keep it aligned. So having this hole in here is called the alignment hole. Now, if you have the sling configured other ways around this, you maybe could get the sling to do the same thing, to hang down and make a hang frame out of it. But having the hole going through this way really forces the hang frame, the whole system, to come together. If you have, say, a hole through here and a hole through here and make some sort of hang system, it might work, but you can't force the boards to really come together. You want this hole in the middle because the boards have to come together in the same plane. That's why this system works. So I'm just going to chop off the other end of that leg there, pull off the string, and then we're going to call it good, and we're going to have ourselves a rigging party. So from here I'm going to go 20 centimeters, 8 inches from the last bowl. I'm not going to be super accurate with that because it's really not that necessary. It's just as long as it keeps some sort of distance away from that fulcrum is all we really need. All right, there we go. Now, oops, we have a hang frame that's a little too tall for my garage. So let's bring this out here. And let's rig up a makeshift slackline. So with the hang frame, what I'm going to do with this sling, I'm going to wrap it on either side here, and boom, just like that, I've got a nice solid steady hang point for this hang frame. So what I'm going to do is grab my shackle, and get my anchor sling through there, get the shackle through one side, get the shackle, get the shackle through the other side, then my lock. Oh, about to drop it. I got it. All right, and here we go. So, I'll move the feet over a little bit, line it up to line, give it a bit of pre-tension here. I've got to work really hard for that. And here we have a hang frame. Whole thing done up. Now, if you take a look up here, you can see what's really happening. This anchor material and then the web lock are solidly connected. There's nothing interrupting the connection between the anchor point and the slackline and the web lock. So all of the system is just the same as you would ever rig it. Very solid connection point. And the only difference here is that the hang point is holding up the shackle. That's all it's doing, and it's holding up quite nice and level. It's, you know, the shackle is really solid in here. Now the neat thing about this is if I pull one side or pull the other, and nothing about the hang frame is really going to move that much. In fact, I can move this a whole bunch here, and the A-frame will very, very quickly come to the center point and come to stasis. Furthermore, left and right really have to have a lot of force going on, and mind you that this slackline has basically no force on it right now, so that movement you're seeing is a bit more exaggerated than would be when it has some actual walking force on it. But you really have very solid left and right lateral stability on the hang frame as you see it here. So with this video, you've seen the entire way from the ground up on how to build a hang frame and really how simple it can be. You know, you can also get a slightly larger sling in here or a longer sling. You can even, what I was using is accessory cord, 6mm, and when you do the calculations on this hang point, the sling is going to be your strongest point. And going around the edges of this, in fact, I have had some really heavily surfed slacklines, and you don't see not even the slightest amount of abrasion here. It's really not an issue. Obviously the wood is in pretty good condition too, but don't think that's much of an issue. And you can see without how the sling is applying the force to the frame. If you have an extra long sling, these inward facing ones are going to apply a little bit more force to the frame and cause some inward flexing on that. But again, from what I've seen on that, from the examples I've worked with and the testing I've done, it's really not that much force compared to other forces that can go on the frame. So keep in mind, you're applying the force cross grain on every point of this hang frame. These slings are not going to be necessarily pushing down along with the grain. They're actually going cross grain. And the splitting force here is really minimal. I don't think it's really much to worry about at all. Even in the brake testing that was done on these, you saw pretty much no damage whatsoever here. It's very, very solid. And so you can see that all the forces are going across the grain on this system. And it just makes it really nice, really simple. I prefer it much over the previous version I did of these, which had these hinge plates. I never really liked that, but that was the best solution I could find at the time. Since then, we've come up with this style, and I much prefer this style of hang frame. Super lightweight, super easy to build, very inexpensive. The whole thing cost me, all the materials cost me $20, and I could have even gotten it for cheaper than that, but I was going with even higher quality wood than I really needed to. So yeah, I hope you enjoyed, and I hope you, if you have any questions, you know, don't hesitate to ask. Hopefully this video was informative enough that you don't ever need to ask a question. But and really what I'm hoping to see here is just more use of A-frames in slacklining. I really think a lot of high lines, a lot of slack lines and long lines, and a lot of different options can really open up if we start using more A-frames. Thank you again. My name is Bradley, and I hope you enjoy the video.